We all enjoy the occasional dip into spaceship stats here, don't we? These things seem to scratch some odd part of the brain for some of us, especially where weapons are involved. As I've said in a few videos recently, big gun, good. Look a little deeper though, and sometimes the numbers provided, while entertaining and impressive, are a bit crazy. Join us on today's video as we look at some examples and see just how insane things can get. We start out our examination of absurd fictional stats with Halo's magnetic accelerator cannons, which to start out with are already kinda nutty with how huge these electromagnetic guns are. Most of the time, the values are sensibly hand-waved away with vagaries, but occasionally an actual number creeps in. So we get fun stuff like the 27-meter bore of the Infinity, or the 3,000-ton, 4% of light speed orbital defense platforms. That's 1.959 times 10 to the power of 20 joules of kinetic energy, or 46.82 gigatons of TNT. To put that in more digestible human terms, I think that's equivalent to the calories in about 600 trillion baby bells. Even comparisons to some other similar weapons in other fiction, like Mass Effect, shows how overpowered Halo's max are. Mass Effect's hand-wavy tech-powered 800-meter-long mass accelerators used on dreadnoughts fire 20-kilogram slugs at 1.3% the speed of light. That's only 38 kilotons per shot. Still way below the potential of Halo's Big Mac, though. But even that is still nothing compared to the insanity that Star Wars and Trek can pull off. Yes, they both have world-destroying superweapons, but even the standard ship armaments in both settings can get crazy. Like in Trek, a couple of basic starship phasers firing together can equal the entire output of the Sun. The episode even explicitly calls that value out, and hilariously has them worrying about maybe accidentally vaporizing a temple with the focused power of an entire star. Yeah, I'd be worried about that too. As mentioned, Star Wars also has some wacky weapons. If you've got one of the cross-section books with the invisible hand in it like I do, then you can follow along at home. On the third page of the cross-section itself, look at the bottom around the middle. The power of the turbo lasers is given as being equivalent to a magnitude 10 earthquake. And what does that even mean? Yeah, it definitely sounds kind of impressive, points for that, but what? Why use that as the scale? Do the turbo lasers shake their target to pieces? And which magnitude do you even mean? There's several to pick from. I suppose it's probably the Star Wars equivalent to the Richter scale, right? That's the common one, and a 10 on that is technically off the end of the scale, which is also logarithmic. That means a 10 is 10 times stronger than a 9, which is already basically total destruction. Someone actually figured out that a real quake that big would involve 3,000 kilometers of fault line all moving at once, and the shaking would last for an hour. Remember, the ship has multiple of these weapons. Sticking with the theme of vibrating things to death with logarithmic scales, one episode of Star Trek's original series had a sonic weapon used for planetary defense. And of course, since I'm mentioning it, a number for how powerful it was provided: 18 to the power of 12 decibels. In normal numbers, that's a tad over a quadrillion. That's pretty loud. Could probably harm a spaceship with that, right? Well, you do a bit more than that, since like the Richter scale, decibels are logarithmic. So 100 decibels is 10 times more powerful than 90 decibels. Imagine how mind-bendingly insane a quadrillion decibels would sound. Damn, those shields on the Enterprise are tough. Now, this trend of weird and wacky world-building numbers does extend beyond just how devastating weapons can be. It can apply to all sorts of things, like transport capacity in the case of Warhammer 40k's Universe-class mass conveyor. This is a 12-kilometer long vessel for carting around obscene amounts of cargo, and up to 500,000 passengers, which does sound like a lot. Spread that out over the, 15-ish square kilometers of the ship, and you get a population density on par with, like, Geneva. Seems reasonable, but that's just through a thin slice of the ship and not its full 5-kilometer height. You could really shove several million people into this thing if you had to. To be honest, you could probably fit a good number just inside that 2-kilometer tall statue there. Good old 40k. Gothic decorations bigger than entire spaceships. The entire ISV Venture Star is smaller than that statue is, and that has the next thing to talk about: engine power. Now, to be fair, there are a lot of specific values surrounding the ISVs that have been cleverly omitted to not run into this issue directly. There's no engine efficiency or total craft mass, but there is acceleration and journey time, and we can make informed guesses based on those to determine that the matter-antimatter engines on these things are ridiculously powerful. I've said it before, but the amazing scene of them landing in the second movie is actually underselling the devastation that would have occurred. The engines would actually be dumping so much energy into the atmosphere that they'd be like a couple of continually detonating nuclear bombs. Each ship would have blown itself up long before it could have dropped off its cargo. The other side of the coin with crazy numbers is when they end up being too small. Like in the Terminator, when Arnie goes into a gun store and asks for a phased plasma rifle in the 40-watt range, which is like an incandescent light bulb. Another quick example is from Lee Brimacombe Wood's excellent Colonial Marines book, which gives the Sulaco some 80 milliwatt point defense lasers, which are 500 times weaker than Arnie's light bulb gun. To be fair though, this just seems like a typo, putting a lowercase m instead of an uppercase one. Now we come back to mass, which is one of those things that is very easy to underestimate. Like that Universe class from earlier, which is stated to be 60 megatons. Wow, megatons. That's a lot. You know what the heaviest building in the world is? 4 megatons, and that thing is only 270 meters on its longest side. Surely the 12-kilometer long spaceship is going to be a bit more than just 15 of these buildings. Okay, yeah, the spaceship isn't made out of thick stone and is hollow, but it's still enormous. Maybe a more fair comparison would be the Seawise Giant, the longest ship ever built, and it would take in the region of 700 to 800 of these empty ships to match the Universe class in terms of mass. How does that stack up in size though? 458 meters of length over 12 kilometers and 68 meters width over 1.3 kilometers, so that's just under 500 Seawise Giants that can fit into the footprint of the mass conveyor. But that's just one layer of them, and you can stack many more on top. So no, even with a fair comparison, this spaceship is still underweight. There's some even more baffling numbers in Elite Dangerous, which also has really low cargo amounts compared to the ships carrying them. Martin Shu on the official forums did the math for this using in-game figures and found out that a Type 9, a big cargo carrier, dedicates like less than 1% of its volume to cargo, and the ship itself has lower density than styrofoam. But to be fair, this is a video game made by many people over a long time, where the stats are more there for convenience's sake than anything else. They're never meant to be realistic, just simple to understand game systems put together to enable you to get space trucking. The thing is, none of this perceived silliness is necessary. Well, I guess the gameplay systems in Elite are, but for everything else, the numbers are just icing on a cake. You don't really need to add every possible number to a design to make it impressive. You can really get away with a lot by not adding them at all. Especially mass. Never provide mass, because it's so easy to get that one wildly wrong. And then some nerd on the internet will make a video pointing out this unforgivable, grievous error. But on the flip side of that, coming up with numbers may be the point. Hard sci-fi projects often do that, going deep down into the details and working out everything as closely as possible. And at the other end of the spectrum, coming up with silly numbers is part of the fun, like the background lore of Star Wars where it's meant to sound cool, or technobabble in Trek where it's just meant to sound impressive and interesting. Having the number be realistic, or even make sense, is simply irrelevant. You can support Spacedock by joining our Patreon, where you can get our frigate, fighter and carrier design reference books, as well as 1 week early access to upcoming videos. Thanks to our supporters, and thank you for watching.